Good morning, students. Today, with the lecture series of differential equation, our topic is when one CF solution is known in differential equation with variable coefficient. Actually, in two methods we have already done. First is the Cauchy-Euler equation, the homogeneous form, and second is the exact form of differential equation. So, this is the third method when one solution of CF is known and we have to find out the second solution. So same the learning object is the student is where more understand about the differential equation and solve the exact formula method. Okay student, now I come to the start my lecture. Okay student, let's see. This type of question like a differential equation given d square y dx square plus p dy upon the linear form of differential equation. This is the linear form of differential. Linear form of differential. Okay. Uh, in this, the first solution depends on the value of p and q. Okay. And this type of question will let one solution, one CF solution is given. Let let y is equal to u is one solution. One solution of C. Then we take y is equal to uv as complete solution. So dy is equal to dx u dv upon dx plus v du upon this is the formula. Now d2y dx2 is become u d2v dx2 plus du dx dv dx plus dv dx dv plus v du dx ये दो इक्वेशन u and v dy dx उठा के हम इस इक्वेशन में रख देते हैं. Then we get a solution by put value 1 and 2 in given equation. So the result d2y upon dx square plus 2 upon u dv upon dx minus p, sorry, plus p dv upon dx is equal to 1. This is the we get. We get this differential equation. And this is differential equation is constant coefficient. Here we get 2 upon u du upon dx plus p value is constant, so the term converted the constant coefficient method. And for the constant coefficient method we know very well that we change to find CF, we find the result by this PI and CF. Now there are some results we have to learn. Then m square plus pm plus q is equal to 0, then imply y is equal to e to the power mx is the solution of Cx. Let m is equal to 1. 1 plus p plus q is equal to 0. Y बराबर e की power. Okay. Second, when p plus mx, when m minus 1 plus pmx plus qx is equal to 0, then y बराबर x की power m is solution. Let put m is equal to 1. So this is 0, px plus pm x plus 2x. So x is equal to 0, and we can say p plus 2x is equal to 0. Then y q बराबर x is solution. Similarly, when we put m is equal to 2, then the solution y बराबर x square. So these are the two results we have to remind what is our solution. Okay, and m square plus pm plus q implies y बराबर a की power mx, and let m is equal to 1, 2, 3. So change in the solution y बराबर x, y बराबर 2x, y बराबर 3 की power. So this type of we find out the CF first. Now we take the solution. Then we take solution. First question d2y. Now we take, actually this method we use when the solution is not given. We use this type shortcut method and put the value of m. When this becomes 0, the solution we can write CF is this, CF is this. Now take another example d2y dx2 minus cot dy dx plus cot x okay. Now the solution. Here we see that p is equal to minus cot. Q is equal to cot x minus. So, so 1 plus p plus q. We check So 1 minus cot x plus cot x is equal to 0. So we can say that y बराबर u बराबर e की पावर x a and px. Now we consider y बराबर uv is complete solution. Complete. So take y बराबर uv e की पावर x imply dy upon dx e की पावर x differentiation is e की पावर x v plus e की पावर dv upon dv है students. So this becomes 1. Now d2y dx2 again differentiate d2y dx2 is equal to become e की पावर x dot v plus e की पावर x dv upon dx plus e की पावर x dv of dx plus e की पावर x d2y dx. ठीक है x plus 2 e की पावर x dv dx plus e की पावर x d2y dx. ये दो इक्वेशन y dy upon dx and d2y dx. ये तीनों हम उठा कर रख देते हैं. We can put in the we put the value of y dy upon dx d2y dx to in given equation and for when we put the value d2y dx2, therefore d2y dx2 value is e की power x v plus 2 e की power x dv upon dx plus e की power x d2y d2v dx. Now minus cot x dv upon dx value e की power x v plus e की power x dv upon dx plus cot x minus 1 e की power x is equal to r is equal to e की power x. We just write just put the value of y dy upon dx d2y dx2 in the given equation. Now after now by solve it we get d2y dx2 2 upon u. We can directly put plus the here dv upon dx we take. So this can be written as dz upon dx 2 upon e to power x e to power x minus cot x z is equal to e to power x sin x upon r upon u. So it is e to power. Okay. Now this become if. This is first order first order linear differential equation. So we have to find out if and write the solution. So if means integrating factor. If is equal to e की power is cancel 2 minus cot x e की power 2x. Okay. Okay, student. So we find out if here. Now, now again we will see this is the first degree differential equation. So we know the solution of differential equation. Just we find out integrating factor. Integrating factor is equal to if. If we can write e की power integration pds. P is here 2 minus cot x. So so become 2x and cot x become minus log cot x. So it is 2x plus log cot x. Now e log cos x would become, and this will become e to power 2x. Okay. Now the solution of equation become z dot if is equal to x upon sin x z is equal to e to power 2x upon sin x Now this change sin x cancel. So this becomes e to power 2x plus z e to power 2x upon. Now now z is equal to dv upon dx. So put we can write here like that z is equal to e to power 2x sin x upon e to power 2 plus c1 sin 2x. This cancel z is equal to become sin x plus c1 sin 2x e to power minus 2. So the equation is become dv upon dx sin x plus c1 sin 2x e to power minus 2. Okay, so and 2x is y. And here it can okay, and this become here out here is 2 r3 2 okay. Calculation is proper. Continue we should check our calculation because some typical part of calculation is there. If small mistake in the calculation, it will be in problem in our answer at last. So dv is equal to become this. So dv can be write as sin x upon 2 dx plus c1 sin 2x e to power minus 2. Actually we take dx this side. Now integrate. Now now integrate. So v is equal to sin x by 2 dx c1 sin 2x e to power minus x plus e. So this will become cos x by 2 plus e to power ax sin bx. Integration of e to power ax and bx will become minus 2 sin x cos x upon 2 square plus 1 square e to power ax. Yes. This becomes 1 by 2 cos x plus minus 2 sin x cos x upon 5 by using this. Here we use this method, this formula. e की power ax sin bx. Dx we can write as integration of this e की power ax upon a square plus b square a sin bx minus b cos bx. Okay, so y is equal to this is the our v and y is equal to u into v. So we know that what is the value of u. So here we know u is equal to e की power x and v is equal to minus cos x by 2 plus you can say minus we take common is minus so becomes c1 e की power minus 2x upon 5 2 sin x plus cos x plus c2. This is the our this is our solution. Or we can also sometime we can write inside multiplication e to power x cos x by 2 minus c1 e to power minus x by 5 2 sin x plus cos x plus c2. This is our solution. Okay, we multiply e to power x inside the bracket. Okay, so this is our solution. That I explain again, students. Let this is our question. We have to solve this. P is equal to minus cot x and Q is equal to cot x minus 1. So 1 plus P plus Q, 1 plus P plus Q we see 1, here 1 minus cot x minus 1. This is 1 cut. 1 से 1 कट हो जाएगा cot x से cot x कट हुआ तो ये आ गया जी. Okay, so we know that when 1 plus p plus q is equal to 0, then the solution is y बराबर e की power x. So we take the one solution we find here e की power x. We can see a solution. Now we take the complete solution is y is equal to u. Put the value of u This is the value of u and v. E to power x. So dy upon dx, what is the dy upon dx? X, this is constant. First, I have done e to power x, e to power x, v as same, plus e to power x same, dv upon dx. Again d2y dx2, e to power x dot v plus e to power x dv upon dx. The first term, this is the first term, and this second term. The first term differentiation is e to power x v plus e to power x dv upon dx. Second term e to power x dv upon dx plus e to power x dv. This value put in equation. This value put in equation. D2y dx2 here, dy upon dx and y. This value we put. Now this becomes d2v upon dx2. All the terms when we solve, we know the direct solution of this equation by solving d2v upon dx2 plus 2 upon u du upon dx plus p dv upon dx. So we put the value of u is equal to e to power x, du upon dx also e to power x become equal plus p is equal to minus cot x and dv upon dx plus r is equal to e to power x sin x. So this is this value we put, and now the equation convert in dv upon dx. So we take dv upon dx as z, equation change in dz upon dx 2 minus cot x z, and this will be cancelled by. Now we know the solution of this type of equation. We have to calculate if. If is equal to this 2 minus cot x. So this becomes 2x plus log cos x e to power 2x cos x e to power 2x upon sin. Now the solution z e to power 2x upon sin x if z if integration 2x if dx plus 0. So z dot this is, and again put with z is equal to dv upon dx in solution. Now we get dv upon dx is equal to sin x by 2 plus c1 sin 2x. dv is equal to this side taken dx, variable separation we use here, and integration. And sin x integration of sin x become minus cos x and sin 2x e to power this is the by the using the formula e to power ax upon a square b square ax sin bx minus b cos x. By using this we get this result of p. But we know the complete solution is uv. We have taken the complete solution is this. So we put the value of v, and u is equal to, we know, already know u is equal to e to power x and v is equal to this. So we put here and get the by multiple. Okay students, I hope अब क्लियर हो गया होगा कैसे इस मेथड को यूज करना. नाउ वी आर मूविंग फॉर द क्यूज. Yes, condition of exact form. The first question asking to you that condition of exact form. Exact form means I told you that when a linear differential equation with variable coefficient, so P2 minus P1 dash plus P0 double dash. Okay. P2 minus P0 P1 dash plus P0 double dash. This is the exact form condition and you have to learn every time. because this is very important concern many times asked in the exam. P2 is the coefficient of P2 is the coefficient of when we write the differential equation exact form, the differential equation of exact form is P0 d2y dx2 plus P1 dy dx plus P2y is equal to Qy. So P2 is the coefficient become y. What is the solution? Can be if 1 plus P plus Q is equal to 0. So this is the here asking about if, if 1 plus P plus Q for a linear equation is 0, then what is the solution? So here I told you one thing. Here I told you one thing that that when 1 plus P plus Q is equal to 0, then solution is equal to u to power. We can also say this can be right as m square plus pm plus q. We check this term. If put m is equal to 1, then 1 plus p, then the solution is u is equal to t to power. But here the solution is u is equal to t to power. ओके, तो m इज इक्वल टू 1 रखने पे हमारा 0 हो रहा है, तो हमारा सोल्यूशन क्या हो जाएगा? y u इज इक्वल टू e की पावर. नाउ अगेन सेकंड रूल, when m when m m m minus 1 plus p m x plus 2 is equal to 0. That means our solution is u बराबर sorry x की power. Here we put m is equal to m. M is equal to 1, this will become 0, px plus qx. So become p plus qx is equal to 3. That means y u is equal to m is the solution. Okay. So again we come. What is the solution when 1 plus p plus q is equal to 0? Just I told you about the method to find out the solution. This is the u is equal to e की power m. If e की power mx be solution, then here he is asking about the condition. E की power mx is the solution. Then m square plus we check m square plus pm plus q is equal to 0. Okay, so the solution is e की power mx. But we अगर convert this statement, we say that if e की power mx is a solution, then the condition become m square plus pm plus q is equal to 0. Where we put m is equal to 1, then it converts in the condition first 1 plus p plus q is equal to 0. Then the solution is we can say the solution is y बराबर e की power m. Now p plus qx is equal to 0, then the solution. What is the solution? Actually I told you m minus 1 plus px plus qx square is equal to 0. Here we put m is equal to 1. So the first term converting 0 become pm x plus qx square is equal to 0. M is equal to 1, then p x plus qx square 0, and we take x common, then become p plus qx is equal to 0. And the solution is y barabar m, u is equal to m. But here m is equal to 1, so solution is u is equal to. So I hope students you are clear in your mind what is the way, so what is the significance of this method, and this is very important because it gives you one solution or not be given one solution, you can decide or you can find out by the simple method. Okay, so I hope ये आपको क्लियर हो गया होगा. All the best. Thank you very much students.